This is an explanation of my Unit 3 project GlowScript code. This is the code I used for this project. This portion of the code sets up the height for the ball on the platform and also allows the user to input a height for the ball on the platform. These next few lines place the ball at the chosen height of the platform and make its radius match that of the PhET simulator. The next lines set up the platform at the chosen height and create a ground for the ball to land on. This next line makes gravity a vector and applies it only in the y direction. The lines following this make it so the user can input a value for the initial velocity in meters per second. These lines focus on the angle of the projectile. It makes it so the user can input the angle in degrees and then converts that degrees into radians. This next line gives the ball a mass. The line following it focuses on the velocity of the ball. It makes the ball's velocity a vector, then uses the initial velocity to divide it into its x and y components, where its velocity in the x direction is the initial velocity times the cosine of theta, and the velocity in the y direction is the initial velocity times the sine of theta. These next few lines set up the stopwatch for the code and start it at 0. These next few lines set up arrows that correspond with the x and y components of the velocity and the velocity of the projectile. These arrows follow the position of the ball and correspond with the magnitude of the velocity. This first line of code attaches a trail to the ball. The following lines set up a graph that will represent the projectile. This while loop occurs whenever the ball's position in the y direction is greater than 0, preventing the projectile from going through the ground that we set up. In this while loop, the force equation is calculated and then used in a variation of equation 9 from our equation sheets to calculate the ball's velocity. Additionally, the while loop also calculates and prints the maximum height of the projectile. This first set of lines sets up the ball's position and makes it so the ball's position in the y direction is put on the graph. The lines following it set up the three arrows' positions as the ball's position, making it so they are attached to the ball. This final set of lines prints information about the projectile. It first prints the total time in seconds, then it prints the final position of the ball in meters. After, it prints the range of the ball. Then it determines the final velocity of the ball using the ball's velocity in the x and y components and a variation of adding the components in quadrature. Lastly, it prints the final velocity in meters per second. Here is the program in action. First, the user enters the height of the ball and platform. Here I used 10 meters. Then the user enters the initial velocity and angle. Here I used 5 meters per second and 5 degrees. Here's the program running. The graph below is a representation of the projectile's position.